Sometimes when we look at a radical function, we end up with things that are called extraneous solutions. An extraneous solution is a solution that we get when we solve it, but may not actually make the statement true. So we're going to solve it and then check if we have any extraneous solutions. You should always check just to make sure. So I'm going to do this example. And this example already has the radical already by itself. So we can go ahead and just start by squaring both sides. Now notice in this one, it's not a number that we're squaring on the right. It's a variable. So that's going to change what we do here. Because as of right now, I have two places where I have a variable. I have 5x and I have x squared. But we've already done quadratics where we solve for something that has x squared and an x value. So we're going to use some of the skills that we learned in our quadratics unit in order to solve this. First, I want to bring everything to the same side of the equation. So I'm going to move everything to the right side because my x squared is already there and positive, and I want it to be positive. So in order to do that, we're going to subtract 5x and add 6. Remember on the right side, you can't combine your negative 5x and 6 with anything because there's nothing else that's a like term. And on the left, we're going to be left with 0. So if you recall, we when we factored everything or when we solved quadratics, we always wanted it to be equal to 0 in order to get the solutions. So we're right back where we were a little while ago with quadratics. We have 0 equals x squared minus 5x plus 6, which is great because now we have strategies that we know how to solve this problem. One of the strategies is factoring, and we always want to check if we can factor first because that is the simplest way to solve a quadratic. So remember, when you factor, you're going to look for two numbers that multiply to be the end and add to be the middle. I see that this sign is positive and this sign is negative, which means both numbers have to be negative so that they multiply to be a positive and add to be a negative. So if you need to refresh your brain about how to do this, you want to list the factors of 6, and you know that they're both going to be negative. So I have negative 1 and negative 6, or negative 2 and negative 3. The ones that add up to be negative 5 as well are negative 2 and negative 3. So now remember, we're going to make our two parentheses. We have x minus 2 times x minus 3. And we're going to set both of those equal to 0. So I get that x equals 2 and x equals 3. But remember, I told you at the beginning that we could possibly have extraneous solutions. Not to say that every time you do this you will have an extraneous solution, but you do need to check both solutions every time to see if either of them are extraneous. So the way to check it is to plug both of them in and see if they equal what it is. So I'm going to start with the x equals 2 first. My original equation was the square root of 5x minus 6 equals x. And I'm going to plug 2 into both of those x's and see if I get a true statement. And I got that 2 equals 2, so I know that x equals 2 is 1. Now I'm going to check the other one to see if it's a solution or if it's extraneous. Again, my original is the square root of 5x minus 6 equals x. So I'm going to check for x equals 3, which means this time I'm going to plug 3 into both x's. I got that 3 equals 3. So both of these solutions are solutions, and in this case you don't have anything extraneous.